Once it does, there we go. So this black mirror, we should know, is a concave mirror, because remember, cave, I always tell you, think about thinking inside a cave, how it's like burrow, like animals burrow in a cave and you look inside. And if you were able to actually hold this black mirror, you could kind of tell that it's curved, like the way it's curved in like that. Remember a long, long time ago, like the very first day we had this online school thing, I had you guys get a spoon and looked at like the scoop of the spoon and the back of the spoon. The scoop of the spoon is called a concave mirror. The back of the spoon is called a convex mirror. Those words are very, very important. Yes, I am saying this on purpose. They are going to show up on a test that we have probably before we leave. And you guys might be like, test, how are we supposed to do a test? There are some questions that I think, like if I would say the black mirror is considered a flat mirror, curved mirror, convex mirror, concave mirror, like you guys should probably be able to answer that correctly, right? And so there is gonna be some sort of assessment or some sort of test. It's probably gonna be some where you have to write stuff out. You guys know how to do ray diagrams, correct? We've done those. We'll review them some more. Don't worry. It's not like our test is tomorrow. We don't even have class tomorrow. But we'll do some ray diagrams to remind. But you might want to like look through some things and maybe watch some old videos if you, some of the ones where I was showing you those things. But this right here is called a concave mirror. Okay. If I am holding this concave mirror, the way it is curved is not going to change. That means if the focus of this mirror is 10 centimeters, it doesn't matter if I'm holding the mirror right here close to my camera, if I'm holding the mirror far away back here away from the camera, the curvature of this mirror does not change if I'm holding it close to my face or far away from my face. The thing that changes is the distance to my nose. So when I'm right here, the focus of this black mirror, let's just say it's 10, just to make it easy. The focus of this black mirror is 10 centimeters. So if I hold it right here, my nose is only a certain distance away, but the focus is 10 centimeters. If I hold the mirror back here, the focus of the mirror is still 10 centimeters, but my nose is a lot farther away. If I turn it like this and try to look at the back wall of my classroom, the curvature, the focus of the mirror, is still 10, but the object, the back of the room is just really far away. Is that process making sense?
Yeah, that's like
what?
Yeah. Okay, yeah. I get it.
Okay. So here's the deal. If you guys look at your worksheet from the other day, and I have no idea how number 8 got skipped. It might have gotten skipped because I put a page break in the middle of it.
Yeah.
I kind of cheated on mine because I was doing something. Did you notice that the focus for the first problems, and I know I wrote in pen and it's kind of crazy, it's written to the side. Did you notice that the focal length was always 9?
Yeah. Yeah.
For the first page, at the end I changed it. For the first page, the focal length was always 9, but my number kept on getting farther away. Look at how this number changes. Okay? And we talked about that before. I would listen to this and maybe write it down on a piece of paper. As the object approaches infinity, the image approaches the focus. That is why the very last problem you guys have, numbers, not the very last problem, but number 7, you plugged in a number of 5,000. 5,000 centimeters is a long distance. That's 10 meters. That's like 10 yards.
Miss James.
Yes.
I feel so retarded. I forgot to send you my work with the answers on it. Like all I did is just the work and it's not the actual answers.
Okay. Where did you put your answers somewhere else or what?
I just forgot to plug them in on Desmos. I wrote it all out. I remember because I was like, I might as well write it all out. And then
you never plugged it in?
I never plugged it in. I completely forgot.
Okay. If you want to plug it in and like resubmit it, it's like obviously if I have one with the work, and then if you want to submit the other one too, that's okay. I know because it was one of those things where it was like, oh yeah, just plug it right.
Like repeating the same steps. So
it really was.
Oh, you got my email, right?
I did get your email. Hi, Brianna. I did get your email, Taylor. So
okay, cool.
If you noticed,
Yeah, we
Jeff,
can.
can you repeat that thing as the object approaches thing?
Yes, I can.
Shut up,
Okay.
Jeff.
As the object approaches infinity, the image approaches the focus. Okay, and for those of you who have the work done and you have your work written out, you will notice on number 1, the object was only 5 centimeters away, then 10 centimeters away, then 15 centimeters away. That right? Do you see how that went? Those of you who have the worksheet and worksheet. Okay, what happened to our answer? Well, the first time I got to talk about why it was -11. I talked a little bit about that the other day, but it's going to be more important today. But our answers for the second one went from 90, 22, 16, 10, 9.5, 9.02, 9.0 something else, 9 point, and I know you're like, we didn't get that many answers, but I got to tell you, what is the number 9.02 really, really, really close to? Basically, the number 9.02 is just the number
9.
which, by the way, what was the focal length for all of the problems for the first chunk of problems?
9.
9. Okay. Making sense there? A little bit.
Yes.
Good. All right. So here is the deal. I think I covered this a little bit the other day, but I want to make sure. Okay. So I'm going to move my computer a little bit closer to the board. Do you guys want the lights on or yeah, I think I should turn the lights off. Let me know how it looks though.
Turn off the lights. I'm looking for.
The board still looks okay, right?
Yeah.
Okay.
Mm-hmm.
So here is the deal. Remember, if we are dealing with a concave mirror, that means it's curved this way, and our main axis should go this way, and our focus is on that side. So I want to do something for you guys here. And I don't think the green always shows up the darkest, but that's actually okay. We're going to pretend that I was teaching you pre-algebra or algebra 1 or whatever. If I put a number line here like this, and I had something starting right here, wouldn't you agree? I know it's kind of hard to read this green. That's why I did it in green. Wouldn't you agree that if I go to the right, it is positive? But if I go to the left, it is?
Negative.
Everybody agree with that?
Mm-hmm.
Well,
Yes.
if you think about it, we've done ray diagrams before with a guy with the F right here. And a lot of times we've done the ray diagram where the arrow's all the way over here. Remember, that would be far away. Well, if we did that, let Miss Javs just do a quick sketch. Do you see how when I do that, the lines meet right here on the positive side of the mirror still?
Hold up.
Does everybody see how the arrow would be right there? It would be upside down. It would be on the positive side of my number line though.
Uh-huh.
Mm-hmm.
All right. But that arrow was upside down, correct?
Yeah.
Yeah.
Okay. Would you guys agree, from where I'm sitting in my classroom, the back of the room is a really, really, really far way away from this mirror? Okay? How would you like to tell me, oh, with the lights off, it's kind of hard to see because of everything. How does the back of the room look in this mirror? Does it
Upside
look
down.
right side up? Does it look upside down?
Upside down.
All right. So
Upside down.
when my arrow was upside down, that was far away. Okay, I could do this with my face, but you guys are actually going to try to look for my computer. And actually right there is Brianna Tucker, and right there is the M for Madison. Are they close to this mirror right now, or are they far away from this mirror right now?
Close.
And if they're close to the mirror, like, does that look like Brianna's symbol the right way up? Does that look like Madison's symbol the right way up, or are they upside down?
Right
Look
way
the
up.
right way up.
When you're
Right way
close
up.
to the mirror, your image is right side up. So this one was kind of a trick. And again, I will put them back on there, and I think they're still on there. But if I draw an arrow, whoops. If I draw an arrow that's going up right here, this was a tricky one. And this is one of them that, again, I will maybe do another like YouTube video to go through it again. Remember, we're supposed to go straight towards the mirror. So that black line is going to represent straight towards the mirror. And then let me see if this is the blue marker that works well. Yeah, that's the blue marker. The blue marker is going to be bouncing off the mirror. Do you agree? Hopefully you can tell the difference. Is that blue line going through this dot that says F?
Yeah.
Yeah.
Okay. Remember, the second time when it's here, it's the weird way we have to do it. Remember, we're supposed to go towards the focus first. But this line will never hit the mirror unless I go this way. Do you guys remember how that time when we did that one, we kind of had to make it a weird line like that?
Mm-hmm.
Now we want to bounce straight off. Everybody agree that blue line is straight off?
Yeah.
Yeah.
So here's a weird question. Where does this blue line meet this blue line? Where do those blue lines meet? On the
Negative
little, yeah,
side,
that I was gonna say the curve
like
side.
past the mirror.
past the curb side over here, and look at what this says in green if you can read it. That is the negative side of the mirror. It's kind of weird to think there's a negative side of the mirror, but let's think about this. Here's another fill in the blank for your test, by the way. What does a mirror do? A mirror reflects
Reflects.
Yeah,
reflects
reflect.
light. So if my hand is on this side, in between the camera and my mirror, where would we expect the reflection to be? On this same side. Like this is the good side. I'm going to hold it this way. If my hand is here and it reflects back, I would expect the image to be on
The
this
same side.
this side back here is the bad side. Make sense?
Yeah.
Mm-hmm.
So when we get that is a negative distance, that means it's not really there. Did we talk one day about something called a real image and then something called a virtual image?
I think so.
I think
so.
I
I
can't
believe
specifically
you have.
remember.
I'm going to make sure we know for sure right now what it is. I know we've done it before.
Yeah, I don't feel like we
because-
talked about it a lot though.
Yeah, not a whole lot. Because I'm using a mirror, I got to turn the camera this way. Does everybody see the window?
Yeah.
Mm-hmm.
If I hold this black mirror up this way, would you agree the windows are on the shiny side of the mirror? Because this is the bad side of the mirror, right? The back side.
Mm-hmm.
So the shiny side is towards the window. If I go like this, am I gonna be able to get an actual picture of the windows on this piece of paper? You guys see the picture of the windows on this piece of paper?
Yes.
Yeah. So I could actually project a picture on here.
Mm-hmm.
I could really project it on there. When you get an upside down arrow, that means the image was real and we could put it on a piece of paper. Okay? When you get an upside down arrow, that means the image is real and we could actually project it onto a piece of paper. That's how actual cameras work. Like digital cameras work very similar as well, but real cameras, when you had to use film, the light would go through there. And in the really olden days, they actually had to leave the light bright enough that it would kind of burn the paper. Did you guys ever hear that? That's how real film works. It gives really quick bright light and it kind of burns the image on the paper. And that's why in the the really old cameras, you couldn't open up the back of it in the middle of the film because it would ruin all the pictures because there would be so much light exposure that it would ruin all the pictures. Okay?
Mm-hmm.
So here's the deal. If you have a camera like this, it is curved like this, meaning the focus, I'm going to hold it this way. It's curved like this. That means the focus is on this side. And that means that the object is also always on this side. Does
Mhm.
anybody know what the other name for the other type of mirror is? What's the other type of mirror?
Convex.
Convex. We're going to talk about a convex mirror real quick. So that first one I had drawn there was concave. This next one is going to be convex. All right? What's so funny, Ronald?
Huh?
What's so funny?
I got a text message.
Oh. All right. Would everybody agree that it kind of is curved like this? Can you see the board okay, guys? I just want to make sure you know.
Mhm.
Yeah.
And remember, this is the side that the object is on. Would you agree?
Mhm.
But where is the curved side and their side? Therefore, where is our focus?
Hold on 1 second.
Say it again, Ms. Jones.
Yep. Would you agree that it's curved this way, but that means the object is going to be on that? This is like when we're looking at the back of the spoon.
Yeah.
Would you agree your nose is on this side of the curve,
Yeah.
but the focus, obviously where it's curved, is on this side?
Right.
So wait a minute. Remember how I said if I was teaching you like algebra 1 and pre-algebra, something like that, and I pretended that this line right here was 0?
Mhm.
What's about this side?
It's positive.
And what about this side?
Negative.
So that means that on this one, guess what is probably true about your focal length?
Negative 2.
Yeah. So this is a big note everybody needs to either write down right now or later when you're watching this video. And in a minute, when I share the new worksheet with you, you realize what's going on and you can do it. Everybody ready?
Yeah, you good.
All right.
Yeah.
When I use the equation with a convex mirror, my focal length will be negative. When I use the equation with a convex mirror, my focal length will be negative.
All right.
When I use the equation with a convex mirror, my focal length will be negative. All right, guys, I know sometimes when you're on Google Meet with me, it takes a minute to load, but I am about to enter something that's called worksheet number 2. All right? I will read question number 1 for you, and I would recommend writing it down with me. The work I'm about to do on the board, okay? But question number 1 on the new worksheet I just gave you. By the way, the new worksheet, since we knew it would be better for us to have the equation rearranged, on the new worksheet, I already have it rearranged for you.
Mhm.
The new worksheet says an object is placed to 25 centimeters from, now, so that's why I started right 25 and then I was like, oh no, they need to know that 25 is DO. From a convex mirror, I'm going to write a star right here because I need to know that it's convex mirror. And I'm going to talk about mirrors in just a second too. If it's a convex mirror, what did I already say we have to do with our focal length?
Negative.
Very good, right? Did everybody just write down if I use when I'm using the equation, if it's a convex mirror, I have to use a negative focal length?
Yeah.
Yeah.
All right. So the next part of this question says that has a focal length of 9. What am I actually going to write down? F equals?
Negative 9.
Negative 9. All right. If we remember our rearranged equation, But remember, we don't want to remember it this way. We want it to be flipped upside down.
So -1.
Mhm.
Ooh, which I might have forgotten to take the fraction off of this side on the worksheet. I might take the worksheet off for just a second because I got to check for sure. So go ahead. Yeah. I just didn't put it to the -1. I just didn't put it to the -1 today.
Yeah, it's the same thing.
So remember, we got to take that side to the negative first power if you're using Desmos. Remember, Desmos makes it pretty quick and easy for us. So we know
So it is. So you don't have to fix anything. It's right
what's right.
on the worksheet. You said we might have to take it off because something was wrong with it.
Yeah, I won't have to take it off.
Okay. So we still putting it to the. So even though we changing the focal points and we making it to the focal length and making it negative, do we still put it to the -1 or no?
Yes, you still put it to the -1.
Okay.
Yep, you still put it to the -1. So I got, when I plugged that value in right there, I got -6.6. Had anybody else tried that yet and got -6.6?
No, not yet.
Okay,
I'm doing it now though.
okay.
With this, I just plug it in. Like I just plug everything in normally.
Yeah, the only thing is, Shariah, if you look at my Desmos right here, because I want to solve for I want to solve just for DI, not 1 over DI. So since I want to flip that, and by the way, I explained that a little bit in the video that you said you started to watch, but maybe didn't get all the way through, okay? Since I want to flip that over, remember that's the inverse. That means flip it over. That's why I put -1 right here. So if I look at Desmos, would everybody agree? Because my focal length is supposed to be negative, I should have 1 over -9, which I know looks kind of weird. Who cares? Desmos can handle it. And
Right,
minus the 1 over 25.
to the -1. Okay.
And did you get -6.6 like mine is showing?
Yep, got that.
All right. Hold on a minute. If DI equals -6, wait, DI equals negative. Sorry, I know the green marker does not show up the greatest. If DI equals negative, what side of the mirror is that on?
The left.
On the left side. And the focus is also on the left side. Okay. It
Right.
was on the same side as the focus, which we've actually noticed before on our ray diagrams. When I would do those ray diagrams, and again, I'm going to probably over the weekend try to do a couple more ray diagrams and maybe try to do them in a little bit of a different way that you can see me drawing them as I'm doing them. As I'm speaking. So it's not like you see it, I put down the paper, you see it, I put down the paper. Negative means it's on the same side as the focus, which once again is why when our mirror is curved that way, it's always on the other side. Oh, guys, the other day, I'm telling you, I think about physics and you guys all the time. The other day I was driving down the road and the car, it was actually a truck in front of me. And it's a little bit of a newer truck, probably made within the last 5 years. On their driver's side mirror, had the bottom part of their mirror, the very outside of the mirror, it had just a little mirror, but it was that extra curved mirror on the side to help the truck driver see a little bit more. Who knows what I'm talking about? Who has seen those driver's side mirrors? Right?
Yeah, I know what you're talking about.
Yeah, that curve right there is called the convex mirror, and it helps to see more of what's out there. To make sure that there's not a car in your blind spot or anything else like that. Okay, so if you ever see one of those vehicles with that extra curve mirror to help them see more, that's called the convex mirror. No matter how close you get, do you ever flip upside down? No matter how far away you get, do you ever flip upside down?
No.
Okay, so that always means you know how a minute ago I said, oh, if we can put the window on this paper and it's upside down, that means it's a real image.
Mm-hmm.
Okay, if an image is not flipped upside down, it is called a virtual image, right? So the two options for our images are real or virtual. And I know we've mentioned that before, but I agree with you. We haven't talked about it a lot just because of what we've been doing and how our this year has gone. But would you agree with me? We have at least mentioned that an image, could be real or virtual.
Yes.
Yeah.
Yeah, right. Okay. So if it's something where your two rays act like if you do a ray diagram and they actually meet, that means it's going to be real. It also is real if it's flipped upside down. If it's right side up, it's virtual.
Right.
Okay. If it's right side up, it's virtual. And I got to tell you something.
Hold on, let me write that down.
On a
If
convex,
it's right side
Wait.
up.
if when we do the ray diagram, your arrow is going the same way as the original arrow,
It's virtual.
it's virtual. So like if I was doing a ray diagram and my original arrow was pointing up, and when my rays met, my final arrow was also pointing up,
Mm-hmm.
that is a virtual image.
I did not know my phone was on mute. I was talking the whole time.
Oh,
Especially when he was talking about the little truck drivers.
oh yeah. I was like, there's a couple people commenting. That's okay. I know. Well, since you guys don't like, there was one class I was teaching, and like, you know how you guys can always see me because I always have my video on. And I started doing something, and I was like looking at it, like going like this, and somebody goes, "Miss Jazz, we can't hear you. You're muted." And I was like, but like,
No,
if
like I really was talking.
yeah.
And I never pressed the mute button, so I don't.
Ms. Jackson, if you're doing a ray diagram and both arrows are growing up, then it's virtual.
Then it is a virtual image. Yes, ma'am. Okay.
Okay.
And then what's the other thing?
The other one would be called a real image. And you will know it's a real image if the image is inverted. So just think about inverted means flipped upside down.
Right.
Okay. So most of the time when we brought Ronald, actually, we can't hear you.
Ms. Japp, so would it be like, would the original image that we get be inverted or the one that we find?
Hello?
Now I can hear you, Ronald.
No.
Shariah, that's a good question. Here's the deal. It actually could be either one. I know that sounds weird, but if let's say your original arrow is pointing up, if you find the final arrow going down, since one was up and one was down, those are inverted from each other. Okay?
Oh, so one is going to be up and then the other one will be down.
Yep. One would be up, one would be down.
Sorry, I'm just trying to get it in my notes.
Yep. Ronald, did you have a question, or you were just trying to make some comments on things and couldn't?
I was talking, and I thought y'all were just being mean and ignoring me.
I'm sorry, we were not.
Yeah.
Were you
We tried.
asking, or you were responding as well?
No, I was just responding to questions
Okay.
that you were asking.
Okay. So do you guys think you know a little bit better about real and virtual images? Does that help a little? I know we've discussed it before, but how in depth we've discussed it has been kind of like, because when we would do ray diagrams, I mentioned it once in a while, but okay. Now a couple more questions so that the rest of the worksheet goes, the rest of the second worksheet goes up pretty well. Does anybody know that we did not just study mirrors this chapter? We also studied something else.
Lenses.
Yeah, it was
Very good. Mirrors and lenses. So
Yeah.
here's the deal. Mirrors, you know about a concave mirror. And right
Yeah.
here on the board, we said if it's a convex mirror, what do we have to do to its focal length?
you have to make it a negative.
Very
Yeah.
good.
Make it negative.
Now here is another guaranteed fill in the blank for our test.
Okay.
Okay. A concave mirror is like a,
Lens.
what type of lens?
Oh, I can't remember.
Virtual.
There was one day, I know I drew it on the board and I drew them next to each other, and everybody in their mind always thinks that goes the other way. Everybody always thinks a concave lens is like a concave mirror, but you got to flip them around. If you remember, wouldn't you agree that I said a magnifying glass? You might want to write this down too. A magnifying glass is what we would consider a convex lens, because a convex lens is thicker in the middle. And like we can get our, does my eye look kind of big right now when I'm doing this? Maybe a little
Yeah.
bit.
You said a magnifying glass is like a convex mirror.
Yes.
Yes.
All right. But if I have you guys look at the window out there, does that window look right side up or upside down? Does it look bigger or smaller? If you're looking through the lens,
It looks bigger.
Bigger.
okay? But then what about if I hold the lens this way and I hold up this piece of paper and I go like this? What can you see projected onto this piece of paper?
The windows.
That means that this picture right here is a real picture. Can you tell those windows are flipped upside down?
A little.
Not really.
Yeah, it'd be like if you would be in class, it would definitely be obvious that they were flipped upside down. Like you could see that. Well, and here's the truth of the matter. Earlier today, it was kind of bright. Right now, it's not the brightest time, and I could maybe move the paper in or out to make it clearer. And that's what I'm talking about. If you're in a movie theater and it doesn't look clear, it's probably because the screen is not in the right place. Because do you see how when I move this a little bit, it goes in and out of focus?
Yeah.
Like that looks way too blurry. It's hard for me to like that looks maybe kind of clear, maybe a little bit clear, but then all of a sudden it kind of fades away. That's pretty out of focus again right there.
Mhm.
But
Yeah.
that's what that means. This convex lens just made a real image. You know why? Could you see that picture on here? Could you see that actual picture on this piece of paper?
Yeah. When you
That means
do-
it's real. And was it inverted?
Mhm.
The original windows were right side up. The inverted ones, that means it was a real image. Okay. So here's the deal. Here's another, man, Miss Jebs is just giving away all her answers today. A convex lens can make real images.
A convex
A
lens.
convex lens can make real images. Oh yeah, what type of mirror is this? Is the black mirror? What type of mirror is the gray mirror? A mirror. This one's actually concave. Remember, the mirror is opposite. So a concave mirror can make a real image.
Okay.
So a concave mirror is like a convex lens.
There you go. Which means a concave mirror is like a convex lens.
All right.
And I'm going to say something that people are like, Miss Jebs, you just goofed up what you said. And I'm not really going to goof up what I say. It just makes logical sense. If a concave mirror is like a convex lens,
Then a convex mirror is like a concave lens.
very good.
Mhm.
Right. It'd be the opposite.
Because it's like they're opposites of each other.
Right.
And
Right.
if you remember when I said we're looking at the back of the spoon, no matter how close I get, does my image ever flip upside down? Like if I was looking at the back of a spoon, if I'd move closer, does my nose flip upside down? If I go really far away, does my nose flip upside down?
No.
Mm-mm.
Do you ever flip upside down when you are on a convex mirror?
No.
So since you don't flip upside down, guess what?
It's a virtual image.
Yep.
Virtual
It's
image.
always, so here's another, geez, why don't I just give you the test tomorrow since I'm giving you all the answers today? Convex mirror can only make
A virtual image.
yes. Mhm.
Yeah.
You said a convex mirror. Okay.
Convex mirror can only make virtual image.
A virtual image.
Now, I'm trying to find it on my phone just because it's a lot easier to show you on my phone than it is to try to do. You guys remember how I shared some pictures with you on a Google Doc that had like the bus and a couple other things? I'm not finding them there, so let me go through my pictures and see if I can find them there. I think I can, maybe not, because I deleted them. Oh yeah, here we go. So like here is a picture This was the one from the doctor's office. You guys know how like in the corners of the doctor's office, sometimes there's a image like this.
Mm-hmm.
Those chairs are really far way away, but if you look very carefully, you can actually tell that room is still upright. Like the windows still go the right way. The chairs are still on the floor. The ceiling is still on the ceiling. I know that's weird to say it that way, but that means that it's not flipped upside down. That is right side up. Okay? Man, think about this. If I was leaving Raising Cane's and tried to look in that mirror and the sky was on the ground and the ground was on the sky, that would be really hard to try to figure out if a car was coming down the road from that way, would it not?
That'd be
Yeah.
great.
So that means that this mirror, was I pretty far away from this mirror in this picture? You should actually be able to tell yes. I was pretty far away from that, right?
Yeah.
Like I was almost across the street from that, yeah?
Right.
What if I was across the street from this black mirror? Okay, I know it's a smaller mirror, but would you please look at the image? Can you guys
It's
see?
upside down.
It's upside down.
Yeah.
Yeah.
If that was
I
a
could tell.
mirror that way, and I was that far away from it, it would have been flipped
Upside down.
upside down. Oh, which means, I think we already kind of concluded this anyway, but guess what that means a concave mirror can produce?
Real image.
A
Yeah,
concave mirror can produce real images, but does it only produce real images?
No.
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 Because think about it, if I get close right here, is that upside down?
Nope.
So if that's not upside down, that means that's right side up, and that means that that is a,
Virtual.
yes. All right?
Mm-hmm.
So, ladies and gentlemen, you know that when I do this, I like to try to keep these lectures kind of short because there's a lot of information. Would you agree we were doing some reviewing today, though, like getting ready for a test? Okay.
Yeah.
I know that a majority of you here are in pre-calculus class with me as well, and I kind of said the same thing, that we're going to have a test possibly. But here's the nice thing about physics and calculus now. They're not overlapping as much as they used to, right? There used to be like the exact same class, right?
Mhm.
But now like pre-calc, physics, calculus are very like set, like all this lens stuff and mirror stuff is like a lot of like words and stuff like that. And calculus, ladies, we do have class on the same day, but pre-calc, like not that I would want to do this, but if I gave like tests near the end of next week, one would be on Thursday, one would be on Friday. You'd still have a day in between, right? Because it's not on the same day anymore, right?
Right.
Okay. So our test is not going to be on Monday. That's the next day we have class. Our test is not going to be on Monday because we haven't really gone over and reviewed and had a chance to ask questions. But seniors, the way you guys are all seniors, the way your schedule works out, I actually only have 3 more days with you after today.
Mhm.
Monday
Oh, that's crazy.
and then Monday.
Mm.
I know, isn't that crazy?
That's
Mhm.
real crazy.
Now, because I've done YouTube videos and they're all still on Classroom, you guys can go back and watch old YouTube videos and like review them and stuff like that. Just to make sure that we're doing okay with ray diagrams. Like I said, I'm going to figure out another way to do a ray diagram so you can like see me doing it as I'm speaking again, so you kind of get confident with doing them. I went through a lot of fill in the blanks, but I would recommend, and I know sometimes I'm like, guys, write this down. And sometimes we did stuff. And sometimes if it was in the video, you could maybe go back to a video and watch it or whatever. But we did do kind of a lot of review today because it is important. And I know the video sometimes with my words, like you guys, a couple of you told me this. And like I said, towards the beginning, I watched it. I might be talking and you can see my mouth moving, but my actual audio does not line up with the way the video is, but at least you can hear it and see it. I will share this with everybody, this video from today. I will make another video. There is, oh, by the way, sorry. The new worksheet, we know on the new worksheet, if it says convex mirror, the work should be really easy again. Would you guys agree the work was not hard, what we did the other day?
Yeah.
Yeah.
Ms. Jabs, I'm finished with it. So for you can keep talking though.
Okay. So would you agree for a convex mirror, we said that focal length had to be negative?
Mhm.
Okay, what is a convex mirror like?
It's
Would you-
like it's like a concave lens.
Yeah,
Very
concave.
So there is a second page of the second worksheet. Like you just have to scroll down. I mean, like if you keep on going, there's more questions. But on page 2, it said lenses, and I even put like, be careful. So if you read something and it's talking about a convex lens, what is a convex lens like?
Concave mirror.
Concave.
So you would treat it like a concave mirror. Would we have to worry about anything being negative for a concave mirror?
No.
Mm-mm.
So that's flip it.
Yep. So for a convex, nope, my fault. For when you're reading the information and you're doing a problem on the homework, that's the worksheet 2, and it says oh, you're working with a concave lens. What's a concave lens like?
A convex mirror.
And what did we have to plug in for the convex mirror?
You have
Negative.
the negative.
The negative for focal length. All right.
Mm-hmm.
Do we all think we can do the worksheet from the other day was pretty easy, and so this worksheet we think is going to be pretty easy as well?
Yeah.
Yeah.
Mhm.
Yeah.
Okay, so I have a question.
If we have some sort of test next week, I mean, I kind of reviewed today a lot of the words and vocabulary type stuff that would be on it. The thing we're going to review on Monday, I will do a few ray diagrams. I might have us do some, and I might watch, like I might actually say, turn on your videos so I can watch you. Everybody, okay with it? Like just that way you know what's going on. And then I would probably have it, unlike last time, for those of you who had the calculus pre-calculus test for me, how I was just like, oh, whatever. Maybe next Thursday when we show up, I'm like, all right, guys, the test should be on there. Like you might have to take it during this like 90-minute time period, if that makes sense.
Yeah, okay.
Okay. And I understand, like, I know a couple of you work and sometimes you have to work at 3 o'clock or just different things like that. I can work with you and we can work things out, especially if we talk ahead of time. Okay.
Mm-hmm.
All right. I think I'm going to hit stop recording. Graduation is the following Thursday, Madison. That would still be like the following week, I believe. Like I'm talking, like that day that you had graduation on that Thursday, and where they're still planning on doing that virtual. Oh, when are you guys coming to do your walking stuff?
That's next Thursday. That's the 14th.
Oh, so that's what she. Okay, so she was.
Yeah.
Okay, I apologize. I did not know what days that was. So next, thank you. I will look at that schedule and see what's going on with that, but we can maybe make a way to work around that as well. Madison, thanks for pointing that out. I thought you meant like graduation. I was like, oh, no, and I forgot about that. They're actually having you guys come in and do some walking across the stage or something like that. Okay. Brianna, was yours like you think everybody wants to know your question? Like, should I just keep recording right now for your question, or should I stop recording?
I would say you can keep recording. I just wanted to know if I had did it right.
Well, okay, I'm going to stop recording then, because if I share this with everybody and then like,
Oh,
you're
yeah,
like,
you're right.
right. And then I'm like, oh yeah, then they don't even have to do like, and I know other people are in here and that's not the worst, but
Right.
all right. So I want to stop recording. We'll wait till it kind of